Hi everyone, it's Mr. H here. This video is all about the Introduction to Functions unit in grade 11 functions. You'll notice the three parent functions shown on the screen. We're going to take those and apply the transformations a, k, d, and c and see what they do to the graphs. Unit 1 is functions and transformations. The first question says, graph the four relations shown, list the domain and range of each, and identify which is a function and why. So the first one is y equals the absolute value of x. So what that means is that whatever you put in for x, y is just the magnitude of that, or the positive value of that. So if you put in a negative value, it becomes positive. So if we graph those on a grid, as shown here, we just have a line that's going up to the right, and then on the left side, it's going up to the left. And so this is a function because every x value corresponds with only one y value. Another way to say that is that every x value has only one y value that comes as a result of it. And so this is a function, so we can use function notation. We can write that as f of x equals the absolute value of x. It also passes the vertical line test. That means the vertical line never intersects the line more than once. So we can now write the domain and range. The domain is x is the set of all real numbers, and there's no restrictions on that. It's going to keep going out to the right forever. It's going to keep going to the left forever. The range is y is a set of all real numbers, but you can see that it never becomes negative. So that means that y is greater than or equal to 0. So there's your domain and range of that first function. The next function that we investigate in this course is the function y equals 1 over x. And so if I put negative 2 in, 1 over negative 2 is negative a half. Negative 1 in, 1 over negative 1 is negative 1. 1 over negative a half is actually negative 2. If it's 1 over 0, that's not allowed in math, so that becomes undefined. If we continue that with the positive values, we get the values shown, and they're just the same as what we had with the negative, except they're now positive. So now what we do is we label the axes. I'm going up here by every square is a half, and then I'm putting those points on the graph like shown, and I'm drawing a smooth curve through those points. Now, you'll notice that when we approach 0, on one side it goes down to negative infinity, the other side it goes up to positive infinity. And so right at that line x equals 0, that actually is going to be a vertical asymptote, and the y equals 0 is a horizontal asymptote. You can see those labeled with the dotted lines. And so that is a function because it passes the vertical line test, and every x value corresponds to only one y value. So we can label that with function notation f of x equals 1 over x. All right, so domain and range. Domain. X is a set of all real numbers. It goes on and on forever on the right, forever on the left. However, right at 0, it was not allowed. So that asymptote is actually going to be our restriction. And the same thing with the range. The y value cannot be 0, and that asymptote is the restriction. Otherwise, all y values are allowed. So now we go ahead and we look at a third parent function, and that would be y equals the square root of x. And so I'm choosing x values that are perfect squares because when I take the square root of them, I want whole numbers. And so 0, 1, 4, 9, 16 gives me 0, 1, 2, 3, and 4. Now, not all these are going to fit on the graph with the grid I have and with the number of squares I have, but I am going to fit at least 3 of these on. I have 0, 0, 1, 1, and 4, 2. When I draw a curve through those points, it looks like that. And that is a function because it passes the vertical line test and because every x value corresponds to only one y value. Now you'll notice if I put negative 1 in, the square root of negative 1 is not possible in terms of the real numbers. And so that is not something that's allowed, which is going to restrict our domain and range here. So any negative values under the square root are not allowed. So that means the domain is x is a set of all real numbers such that x is greater than or equal to 0. And the range has the same restriction. Y is a set of all real numbers such that y is greater than or equal to 0. It touches that point 0 but never goes below it. So now we go ahead and look at the next function, x equals y squared. It's going to look remarkably similar to what we have on the left, but with one distinct difference. Because the y values are squared, I'm going to give the y values first and then square them to determine what the x values are. And so as we do that, you get negative 2 squared is 4, negative 1 squared is 1, 0, 0, etc. And so we go to label those points on the graph, and what we actually get is we have something, as I already mentioned, that looks remarkably similar to what we had on the left, except it's not just that curve on the top, it's also the curve on the bottom. It's a complete sideways parabola. This is clearly a non-function, and that's because there are several x values that actually have two corresponding y values. In fact, every x value to the right of 0 is going to have two corresponding y values, and so that's not a function. It also fails the vertical line test. If we draw any vertical line to the right of 0, it's going to go through the function twice. So you might be wondering, why is this different than what's on the left? Like if I take the square root of both sides of the example in D, does it not become what is C? Well, it actually becomes plus or minus the square root of x. And you'll notice on the left in example C, that was just the positive square root of x. In other words, that when I take x equals y squared, that actually gives me the top and the bottom of the sideways parabola, not just the top of it. And so that's going to make it a non-function. So the domain is x is a set of all real numbers, and you can see that x has to be greater than or equal to 0. And the range has no restrictions. It's going to go up forever and down forever as well. All right, so there we go. Those are the examples. If you want to see y equals x squared, that's coming in a later video on Unit 3 on quadratics. And so you can see how that's being graphed if you want to see that as well. That is very foundational to this course. Example 2. The graph of a general function f of x can be transformed to create the graph of the function g of x equals negative 3f. That's a function of negative 2 x minus 1 minus 4. Describe the transformations that would be applied to g of x. Well, what we need to do first is we need to identify what the a, k, d, and c values are. And so the a value is negative 3, the k value is negative 2, the d value is 1, because the general form is x minus d, and the c value is negative 4. So now what we're going to do is we're going to list how those restrictions apply. Remember, in general, it's a times f of k, x minus d, plus c. And so the a value being negative 3 is going to mean that it is a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. Now the negative also has something to affect that, and that negative is going to flip it over the x-axis. Notice that's a vertical flip. So the x is the horizontal axis, so it's going to reflect or flip over that horizontal axis. It's going to vertically flip. It's very important you keep that clear from what's happening with the k value. So k value being negative 2 means it is going to be a horizontal. Now, it's 1 over 2 is the stretch or compression factor. So this is a compression. 1 over 2 is going to be a half. So it's a horizontal compression with a factor of 1/2. Factor of 1/2. The negative is going to flip it or reflect it over the y-axis. That's going to be a horizontal flip, horizontal reflection, which happens over the vertical axis. All right, so now we move on to d. d is equal to 1, and that means it's going to shift 1 unit to the right. d is always a shift left to right. And the c value, which is the very last value, is going to shift it 4 down. That's always going to be a shift up or down. In this case, being negative, it's shifting 4 down. And so now that we have those transformations, we're going to now graph that on the graph shown. I've set a scale, so every square is 1, just to make it nice and easy to see. So graphing f of x equals 1 over x, just like I did earlier in this video, you can see those key points. We have 6 key points, and then we go ahead and we graph our curve through those. I'm just drawing that first function as a dotted line just so it doesn't get too messy with everything else. There's going to be a lot of functions on here. It's going to be a little cluttered, but that is f of x equals 1 over x. Now we're going to graph it just with the a value, the negative 3 applied. So I'm going to take the value 1, 1. That's the easiest one to start with. I'm going to multiply the y value by 3. So it's going to go up to 3, and then flip it over the x-axis down to negative 3. So there we go. That point transforms down to negative 3. And then when I look at the next point over, which is going to be at 1/2, that becomes 3 over 2, or 1.5, and then flips over the x-axis down to negative 1.5. The point at 1/2 and 2 then goes up to 6, and then flips all the way down to negative 6. And so I do the same thing with all the points on the left. I multiply essentially the y values all by negative 3, and I get the points shown. And so then I draw the curve through those clear points, and making sure those points are nice and clear even after I draw the curve so I can transform those in the future. That labels as y equals negative 3 over x. The a value has been applied to the function 1 over x. So now I'm going to go ahead and apply the k value. For the k value, I'm going to multiply each of the x values now by 1/2 and then flip it over the y-axis. So 2, or negative 2, becomes negative 1, and then it flips over the y-axis to become positive 1 at the same y values now. Same y values. And so -1 becomes -1/2, flips over to become a half. And then a half, or -1/2, becomes -1/4, flips over to become a quarter. And then I can draw my curve through those 3 points as shown. I'm going to do the same thing with the bottom right curve. I'm going to multiply each of those x values effectively by -1/2. It's going to flip it over the y-axis, and it's going to make them become half the distance to the y-axis that they were previously. Now I draw my curve through those key points, and I have it looking something like that. And that is now with the -3 and the -2. So y equals -3 over -2x. And so the last thing we want to do with our transformations is we want to graph the shift right and the shift down in this case. And the easy way to do this actually is to start by recognizing how the asymptotes will shift. Because it's shifting right 1, that means the asymptote that was at x equals 0 is going to become x equals 1. And the asymptote that it was at y equals 0 is going to become y equals -4. And then it's going to have the same shape. In other words, it's going to be the same distance from the two asymptotes and where those join compared to where they were from the origin previously. So if it was over 1 and up 1.5, we're going where those two asymptotes join, over 1 and up 1.5. And there's one of the points there. We're going to continue that pattern with all the other points. There's another point there. I went over 1/2 and up 3. So I'm going to go over 1/2 and up 3. There's another key point. And then that last key point way up at 1/4 and 6 is going to be a quarter from where the asymptotes join and 6 above it. And so we join those 3 points up like so, and that's the right side of this. I do the same thing with the red dots down in the bottom left. I'm transforming each of those right 1 and down 4. You could literally move them from where they are over 1 and down 4, or you can compare where they are compared to where those two asymptotes join, as I already described. And so what you're going to get is you're going to get two of those points that are actually going to show. The third point isn't going to fit on the graph that I have, but it's going to look something like that. And so what we have in blue is our final function g of x. That is g of x. And so g of x, or in this case, I could just write it as y equals as well, but it's equal to -3 over -2 x minus 1 minus 4. So I'm just going to write that out here as well on the left so you can see what that looks like applied to this specific parent function. What was listed at the beginning of this question was those same transformations that could be literally applied in the same way to any parent function that we've gone over previously. I chose the reciprocal function just because it's a little trickier for students to grasp, and it's a good example to look at. So our domain and range, the only restrictions we have on those are the asymptotes. So x cannot be 1 and y cannot be -4. And the equations of the asymptotes are, we already showed those as we graphed those earlier, what's shown right there. So we fully transformed a reciprocal function. We've looked at the parent functions and what each of those are, and we've got a really good summary of what Unit 1 is, all about functions and transformations. For more on how to apply transformations, check out the video on the left. For more on the parent functions and how those are set up, check out the video on the right. Thanks so much for watching.